Hello, everyone, and a very warm welcome to you all. Thank you for joining us today for our webinar, Improving Cybersecurity with IT Asset Management. Today, our presenters will be Al Pooley, Snow's CIO, and Rob Price, our pre-sales consultant. And they'll be discussing how ITAM can be used to shore up your cybersecurity programs, and specifically how Equifax could have leveraged ITAM to mitigate their 2017 data breach. My name is Rachel Loewenherz, and I'm a Senior Product Marketing Manager, and I'll be your moderator today. You may already be comfortable with this platform, so just a quick reminder that you have your Q&A box on the left-hand side where you can submit your questions throughout the presentation. We also have some resources for you to download on the right-hand side. So before we get started, I just want to let you know that when the webinar has ended, you can still access it by using the same link that you've joined us with today. And on that note, I will hand it over to our presenter, Al.
So thank you very much, Rachel. Let me start out by setting out what I'm going to cover over the next sort of 20-25 minutes. So our aim today is to explore how ITAM, IT Asset Management, and Technology Intelligence can help businesses improve their cybersecurity. Security is a topic that's high on the agenda for many business leaders, and because of that, it has both funding and mind share. So let me talk about the sequence. First, I'm going to talk through some common concepts from cybersecurity frameworks and identify 3 key elements where ITAM can solve some of the toughest challenges for the security team. Next, I'm going to talk through a real-world example and discuss what happened at the Equifax breach. We'll then move on to a live demonstration by Rob and show you how we can put some of the 3 key elements that I'm talking about into action. And finally, we'll wrap up with some closing conclusions and time for any Q&A, any questions that come up. Okay, so cybersecurity frameworks. Let's talk about them. These are helpful tools which can assist security leaders in identifying and prioritizing how they can better defend their organizations. There's a number of different frameworks. The SANS Top 20 CIS controls that you can see on the bottom left, the UK's National Cybersecurity Centre Top 10, or even the United States NIST Cybersecurity Framework. Your organization may already be using one of these today, and the choice of what your organization uses may be swayed by the regulations that you operate under. My aim is not to recommend a framework today, but instead to talk about the 3 common elements that exist in all of the frameworks, which are straightforward for you to implement and can really deliver some value to the security team. Okay, so the first area that I really want to get into is to talk about inventory. Many frameworks call this out as a key part of any security strategy. In the case of SANS CIS Top 20, it is literally control number 1. Start by understanding your software and hardware estate. Once you have that understanding, you're able to keep track of both what you're protecting, but also what software out there is running and what you need to secure. Most of the frameworks talk about keeping track of both your software and hardware inventory. And one of the key recommendations I think that we need to be aware of is they suggest using an active discovery tool to identify and keep track of your estate. Just relying on a static way of doing so doesn't give you the up-to-date information that you need to be successful. Now, the second area I want to come on to is patch management. If you work in IT, then you'll know this is not the most exciting task to do. There's a never-ending stream of updates, and it rarely results in a lot of recognition or your boss patting you on the shoulder for a job well done. However, from a security perspective, it's absolutely essential to stay on top of the software updates that are coming in from all the software vendors that your organization relies on. The vast majority of attacks today rely on exploiting known vulnerabilities, where the vendor has already released an update, but unfortunately, the organization has yet to install it. Now, many of the frameworks actually go further than just saying you need automated patching. Rather, they say that you need to search in an automated fashion for vulnerabilities that exist within your installed estate. I think it's important to really call out that you can't rely on just external scans, as they can give you a false sense of security. If an attacker manages to bypass your perimeter security and find a route into your network, say by phishing one of your employees, they can then operate from within your network and bypass all of the strength and controls you've put in around your perimeter security. Organizations which rely too much on perimeter security, it's sometimes referred to as a coconut strategy, hard on the outside but soft on the inside. Instead, the right approach is to ensure that all your systems are kept up to date so that you're not at risk of these kind of things happening. Now, the third area I'm going to pull out from the cybersecurity frameworks is security education. Good cybersecurity doesn't call out people as the weakest link. Rather, it recognizes that we need trained and aware staff to properly secure any organization. And I think this is a key point to make sure that everybody in the business is aware of. And it really needs quite nicely into our case study when we come to talk about Equifax and what happened in their case. So the information I'm going to talk about is firmly in the public domain. The US House of Representatives published a 96-page report which explained what they believed happened at Equifax. To remind those of you who perhaps recall this one or don't remember the details, we're talking about a breach that involved the loss of 145 million names, date of birth, social security numbers from particularly American citizens, 99 million home addresses, just a ton of sensitive data. And I think the key message that we want to go through today is to look at what happened. So let's go through the various milestones that occurred. On the 7th of March, a vulnerability was found in Apache Struts. That vulnerability scored a CVE score, which is the common vulnerability scoring system that everybody uses, of a 10.0, which is a critical. It's the highest you can possibly get because the sensitivity of the vulnerability was so important. Now, Equifax had a vulnerability team. They had people who were interested in this, and they sent out an internal email warning everybody within the technical parts of the business that there was a vulnerability in Apache Struts. On the 15th, they decided to carry out a scan, and they went and scanned their external servers and looked to see if they could see this vulnerability anywhere. They weren't able to find it from that external scan. They followed up with a meeting on the 16th of March, a vulnerability meeting within the business, where they reminded everybody that this Struts vulnerability was out there. It was an extremely dangerous vulnerability and reminded everyone to check that they didn't have it installed anywhere in their estate. The problem they suffered from is they didn't have an inventory. Nobody knew where Struts was installed. They had systems that had been up and running for very large periods of time, and operating for, in some cases, decades. And that meant they just didn't know where it was. So we then move on in quite a period of time, from the 16th of March to the 13th of May. And on the 13th of May, Struts was exploited in one of their pieces of infrastructure, a sort of consumer service that people could go and use and was accessible over the web. Unfortunately, that exploit wasn't detected, and we then have a gap in time of 76 days where the attackers were in their environment, in their network, and able to operate before on the 29th of July the vulnerability was detected. And the reason that was detected was, unfortunately, they repaired one of their monitoring systems. The monitoring system had been broken for 19 months because its SSL cert had expired. And when they finally updated that SSL cert, they immediately started getting alerts about suspicious traffic and suspicious patterns of activity that indicated that they had a problem. So I think a key thing at this point is to talk about, well, what happened in those 76 days? We had the break-in, we had the attackers in the network before they were detected. What did they do while they were there? Well, the first challenge they faced was they hadn't partitioned their internal network very effectively. The servers that were compromised had access to numerous other resources across the network. There wasn't the firewall rules or the internal mechanisms to prevent that traffic. That leads on to very much the second one, which is that the ACES system, which was compromised, had network access and the ability to get to 48 unrelated databases on their network. It only needed access to 3 to do its job, so this was a vast over-provisioning of access, which allowed the attackers to gain access to so much data. And during those 76 days, they carried out 9,000 queries. They pulled out a ton of data. They put it into files, and then they put those files into a web-accessible directory and downloaded them over the internet. So that kind of sets out what happens in that period. So now let's turn to what happened after they detected the problem. So we're now into the kind of incident response piece. 29th of July, we've got the vulnerability detected when they repaired their monitoring system. 30th of July, they take the system offline, the ACES system, and they inform their CIO. 31st of July, they identify that they've likely lost personally identifiable information. It's been extracted, and they inform the CEO. On the 2nd of August, they then call in a third party, a company called Mandiant, and the FBI to help them investigate. And this is pretty common. When you get into these kind of forensic investigations, even a company the size of Equifax needed to go out and get some help to do this. There's then a gap, and it's the 17th of August before they call a senior leadership team meeting. There's then another gap. It's the 24th of August before the board of Equifax are informed. And then another gap, and it's the 7th of September before the public are actually notified that their personally identifiable information has been lost. That means there were 39 days between the site being taken offline and the public being informed. And this really goes to that message around security awareness and education that you need within the business. They needed to be better equipped to respond to this kind of incident and understand what it meant. So, coming back to our original point, how could ITAM have helped? What can we really learn from this incident? Well, visibility of your software estate can give you the ability to react when a vulnerability is found. Equifax actually had 65 days between their own internal emails warning everybody that this vulnerability was out there and the breach. If they'd had the ability to look for the vulnerability on their estate or search for software revisions that had been deployed, they would have had plenty of time to patch it and fix it before this particular hacker came along. Had they been alerted, which would have been one step further on, that they had the vulnerable software in the estate, that could have assisted them even more. So they didn't even necessarily need to go and actively look for it. Rather, they could have had an alert that this vulnerability was there and existed. And I think one of the key things is to note that their external vulnerability test did not detect the Struts vulnerability. They needed another mechanism of understanding what was on their estate. Okay, so let's talk about how Snow can help. Rob?
Yes, thank you, Al. Okay, so the old adage says you can't protect what you can't see. But this is an area Snow specializes in and certainly is a market leader in terms of software recognition and having the highest level of intelligence with regards as what's in use within an environment. So just going to run through some of the speeds and feeds. Snow recognizes over 600,000 applications from over 100,000 technology vendors. We've got deep dive views into and recognition of 18,000 SaaS apps. We've identified within our own unique set of information over 87,000 applications that by design are going to contain personally identifiable information. We have the largest income of information with regards to new applications running at over 6,000 per month. These updates and all of this intelligence is delivered out to our customers on a daily basis. So all that's great when we look for the purpose of software asset management. But what now once we start to move into risk identification? Well, that same intelligence that we can bring to bear for the purposes of understanding our software assets, we can now augment with other data. Primarily, we're linking with the information from National Vulnerability Database, as well as Snow's own bespoke GDPR data. What this enables us to do is to recognize the actual currently installed software package as it exists on any particular given endpoint. We then map that sub-package level out to the NVD so that we can identify precisely a package that has vulnerabilities associated with that. We're then turning that into powerful interactive visuals through our Risk Monitor platform that enables organizations to effectively deep dive into where those risks actually lie. So what I'm going to do now is just move into a brief demo of the product before we hand back for the Q&A sessions. So what we have here is our landing page for the Risk Monitor. And there are two sides to this, as we've discussed. There's the vulnerabilities and the PII risks that we find within the environment. So we're covering a vast number of devices, a very large number of users, and a large number of applications within. But let's focus in on the vulnerabilities piece. What I want to understand is not just what vulnerabilities exist in my environment, but actually which of those are being used by my user community. And this is one of the advantages of the Snow agent, where we're constantly running even when the device is off of the network. So what we're looking at here to the upper right-hand side are vulnerabilities that are within use within our environment. We can see to the lower right-hand side the manufacturers by a number of affected devices, users, vulnerable apps, etc. I'm just going to follow the theme that Al's been presenting here. I'm going to move into what we've called the Vulnerability Explorer. Now, it's through this that we get the ability to deep dive very, very quickly into the threats that we have within our applications. Depending on the framework that you're using, you may have a time-limited period where you need to go ahead and find critical or high-level vulnerabilities as they exist. Snow very quickly and very easily enables you to move around this data and find where you need to make those priorities. So we can look at any particular manufacturer, we can expand within those areas. We can actually look at vulnerability details and drill through and find out exactly where the risks lie and those reference URLs associated. But in the case of Equifax or any other vulnerability scanning that you wish to do, you may want to go ahead and actually search for a specific CVE ID. Now, within our system, we certainly don't have the Apache Struts breach, but what I do have here is some other high-level vulnerabilities that we can go ahead and search on. So in this instance, I can see just by straight ahead searching on the CVE ID that I've got over 14,000 vulnerable devices with Cisco software running on it. Now, one of the things I will also take the moment to point out is these CVE IDs here. This first four set of numbers is the year in which it was published. So the adage is true. Most of the vulnerabilities that are exploited have been known to IT for over a year. So it's a very quick walkthrough. With that, I will hand back across.
Thanks, Rob. Just to really try and wrap up the session then, as we talked about at the start, all the cybersecurity frameworks that we looked at share some common patterns. They talk about the same kind of controls that you want to bring in, whether that's your inventory and understanding your IT landscape, whether it's tracking the vulnerabilities and keeping your systems patched, or making sure that your employees understand how to respond in a security incident. Hopefully what you've seen here is us able to put some of that into action and help you manage your security that bit better. So I think that covers the core part of what we wanted to get through in the webinar today. So if I hand over to Rachel for the Q&A.
So at this point, we're going to open up to some questions. So feel free to submit any questions, comments, or general feedback that you might have into your Q&A box. It looks like there are a couple of questions in there already. So let me take a quick look at the first one. And I will hand this one off to Rob. The question is, how do we account for devices that aren't on the corporate network?
Okay, so Snow has a pretty advanced agent that's running in the background on systems. It's monitoring the application usage and launch of the system as well. So we can pick up, for instance, if, yes, a device is off the network, but maybe something's been loaded by USB or been downloaded for the web. we can account for that as well. So those deltas will be replayed once the device reconnects to the network, and then will be updated into the system.
Great, thank you, Rob. This next one, Al, I think is for you. So this question is about Risk Monitor, and it is, how do I approach my InfoSec team with these capabilities?
That's a really good question. I think the best way to do it is actually to use the cybersecurity frameworks and try and find out if your InfoSec team is actually using one of those. As we talked about, it's very common that whichever one they've chosen is going to need some of the things that you're able to talk about, and you're able to bring this to them and say, look, really like to understand what framework we might be using, how we tackle cybersecurity. Think there's a way that my function and this ITAM discipline we've got can help.
Great. So I think we have time for 2 more questions. And Rob, I'll send these both over to you. The first one is from a current customer, and they're asking, they already have Snow. What do they need to do to use Risk Monitor?
They need to, in effect, do virtually nothing. We need their license key and a list of the users that they would like to grant access to the interface. What we then do is process the data off host between their Snow environment and the cloud platform. So there's no extra agents that are required on any of the devices. There's no extra device impact. So all processing is done off host. Kind of, I guess, think of it as scan once, use many.
Got it. And along the same lines, our last question is also about Risk Monitor. Does Risk Monitor pick up open source software as well?
Yes, it does, but I think there's more weight to the answer than just a simple yes. I think the importance behind the question comes in the form of patches and updates. So commercially available software will be proactive in informing customers and people licensed to use the software of security updates. It's a little different in the open source world, where you've actually got to go and look for those. So certainly for open source code, the ability to pick that up in Risk Monitor is hugely beneficial. Helps helps stop things falling through the gaps.
Great. Thank you, Rob, and thank you, everyone, for your time today. Any questions that weren't answered will get a follow-up after the webinar, which is now available for you to watch on demand at any time. So thank you again, and enjoy the rest of your day.